Hello viewers, this is your host Sushil and I'm here with my new video for you to watch. In this video, I'm going to explain you and give you demonstration about data table option in what if analysis in Microsoft Excel. In Microsoft Excel, I have earlier covered the two major topics which come under what if analysis. Those are Scenario Manager and Goal Seek. I'm sure you must have enjoyed those two videos and this is the third one that I am bringing for you to watch. So in this video, I'm going to give you two examples. One will based on the finance matter and another on the technical matter. Let me get on with the finance matter. Each one of us is interested in earning some way or the other, some interest or the other on whatever savings we have. So whatever savings we have is said to be principal. The rate at which we get the interest is R or rate, and the number of years that we invest our amount or our principal is the number of years or period of savings. So if you see, these three cells are the inputs, whereas when this investment is done at a certain rate of interest for a certain period of years or time, the interest is paid either in simple interest form or compound interest form. In this example, I have considered simple interest, and simple interest is nothing else but principal multiplied by rate multiplied by number of years. So it is nothing else but PRN, and here is the value for the values which are considered as principal. 7% of rate, I'll change it to percent so that it is, and number of years is 3 years. So if I invest 20,000 rupees for 3 years at the rate of 7%, I'll be fetching 4,200 rupees as interest. When this interest is added into principal, the amount is what we get. So amount is nothing else but principal plus interest. Fine. So here I'm going to demonstrate you if at all the rate of interest had been something different, say 5.5, 6.5, 7.5 and so on percentages, how would it have fared and what would have been the returns? It is very much interesting for an investor or an individual to know all these values. So let me give you a demo of how to do this what if analysis and create a data table for this consideration. Now I have chosen the cells which are of interest. So for the given rate of interest, say 6%, 7% and so on, I'll first go and change it to one decimal, and now you can see very much on the screen it is 5.5%, 6.75%, 7.5% and so on and so forth. So for this details or this data tab, I need to find out how much interest will I be fetching. So as usual, go to data, what if analysis and click onto data table. Once I click the data table, I see there are two inputs which are being asked here. One is the row input and another is column input. Now this example is a single input or single variable data table. So in this case, in the column, I am going to check how much interest shall be paid here. So now in the column input, what is variable is the rate. So I'm going to cell number B4 and click onto the value of rate and say OK. Once done, the data table is ready at our discretion, but you can see that all these values on screen are 0. What do we need to seek? So we need to seek the interest or the amount. These are the results. So I'll go to this cell O3 and here I'll say is equal to B7. Once I do that, I get all the values of a corresponding interest as per the interest rates I have considered on my left side. The right side cell gives the value of the interest. In this way, a data table with a single variable can be prepared. So friends, on the left side of yours, where I am highlighting now, I have created data table for variable as rate, variable as principal and variable as year. So in case if my interest rate goes on from 5% to 16%, The interest that will be reaped against it for a principal of 20,000 shall be these values, what you see on your screen. If I see now I want to change the principal values here, or I want to check for these principal values, say 20,000, 22,000 onwards up to 40,000. If at all I go for the rate of interest of 7% and for 3 years I invest my principal, what shall be the interest that will be available for me to use? So as you see, the first value here is nothing else but what we have considered in our earlier input table. So at 7%, if I invest 20,000 rupees, I will be receiving 4,200 as the interest. This was the first value, right? So similarly for variable principals, that is 22,000, 24,000 at the rate of 7% for 3 years, this shall be the values of the interest correspondingly. Fine. So friends, by changing the principal values by keeping the other two variables same, I can find out the interest values those can be reaped. Now in case if I wish to check out as to what amount shall be available for me if the interest rate goes on changing from 5.5 to 16.5%, what shall be the amount that is payable to me? In that case, in this data table, I shall go here and say equal to, and I click amount value here, that is B8, and say enter. In that case, I'll be receiving all the values here corresponding to the interest rates for the amount that will be payable to me against my investment. Right? Okay, friends. With these examples, I have explained you a single variable data table. Now let me explain you how can a two variable data table be prepared herewith. So let us go to this portion of the Excel file here. I'll just copy these cells closer to these ones so that it becomes easy for me to explain you how to use them. Fine. So now let me zoom on to this side of the Excel file and let me explain you how two variable data table can be made. Now in first case we studied a single variable data table wherein one of the variable if changed the result or output could be estimated or could be calculated. Now in this case you see a data table already prepared here. I shall be deleting this data table. If I try to delete a single cell, it's not practically possible. It says can't change part of the data table. So if at all anything has to be deleted from this two variable data table, it is the complete data table that can be deleted. Fine. So now if someone wants to know at the rate of interest of say 5% onwards with an increment of 1% up to 16%, what shall be my resultant output or resultant interest which shall be payable to me for a variable period of number of years, say from 2 years to 13 years with an increment of 1 year each. Let us do that and find out how can I prepare a data table for this. So now I will choose the range for which I need to create the data table. Once done, go to data, what if analysis and data table. Now here again as we saw earlier, there are two inputs which are required. First input is for the row input and second is the column. Now in this case if you see the row input here is the rate of interest. So I'll be choosing the rate of interest as the row input, and for the column input I see the number of years are the inputs which are required. So I'll be going for column inputs as number of years. So I'm going to choose B22 here. Once done I say enter and here is the data table readily available for me. Now, you may be wondering how it happened because in the initial phase before I started doing this, I had chosen this cell as is equal to B7. B7 was nothing else but the interest value was what was of my interest here. So I chose it to be B7 and this is what the interest rate which was popping up for all these values. Now, I need to change this now as is equal to B7 here, or rather B24 here, and say enter, and I will see now it has got replicated as interest, which is applicable for this interest rate and for this number of years. So with this, we have seen that by changing or by defining the variables, first one as rate and the second one as number of years, the derivative of this as a result can be found out as the interest, which is seen in this portion of the table, right? So if someone wants to check that at the rate of interest of 14% for 12 years, if I invest rupees 22,000, what shall be my amount or the interest payable to me? So it is the interest here, and that will be 33,000. So in this way, this data table can be very well used in many applications. For example, if one wants to give a loan premium every month and he needs to know at the 60th month from now what shall be my premium value, it can be derived by using this data table. If some person wants to do a insurance policy with the company and wants to understand what shall be the premium payable for him, say 25 years 3 months from today, and it can be found out from the data table if created for that period and that policy. In this way, there are multiple applications of data table. I have demonstrated you a very simple one so that it becomes clear to you how data table can be created and how it can be used. Now in this case, if I go to here and say is equal to, and I choose the amount cell here and say enter, as a result, the data table will get converted into the amount table, and here I can see for the rate of 15%, if at all I have to understand what shall be my resultant amount for investment of 13 years, I can clearly see here amount is very much 59,000 if I invest 20,000 as initial principal today. So in this way, variable results can be found out depending on what is chosen in the data table. So friends, as I explained you in the two variable data table, I had shifted or I had changed the result values from interest to amount and amount to interest. Same way, I'll demonstrate it to here in a single variable data table how it can be done. So when I had chosen as the result as interest here, had I chosen the result as amount, I would have received the amount values as outputs here. Now, in case this becomes very confusing for someone that sometimes he sees rupees 24,200 as the output here, which is nothing else but the value in the B8 cell. Let us make it a habit to hide this cell and make it common. Like I had done it here. In this case, I had done it in this case that this cell was seen to be blank, though it has got variable multiple values inserted in it. Now, how did I do it? Let me show you in this case here how it can be done. So right now, what you see on your screen is the rate is variable in this case, in this data table. The values that we see here are the values for the amount that are payable as per that interest, and here was a cell that we had chosen how to or what should be shown there. So on this cell, I'll say control 1 and I go into the data format option. In this I choose the custom, and here I choose the three lines hyphen and say OK. And now you see the value here, the cell will appear blank to the viewer, but this cell has the value of is equal to B8. If I click on it, it is seen over here. It is seen over here, it is B8. Okay, the value of F3 is B8. Fine. So, sorry. Coming back here, if I want to choose it as an interest, I can say is equal to and choose the cell B7 and say enter, and I'll be able to see the interest values here. In this way, only by choosing these cells and for the variable rate interest, what can be my payable interest and what can be my payable amount can be very well found out from this table. Friends, let us go on to the next example of technical details. Let us go on to the next worksheet and see how we can understand this. Now, in this case, we have taken an example of a construction of water tank. So water tank is generally cylindrical, which is circular at the bottom and having a height of length L. Say, for example, here in this case, I'm going to show you the data table. I have made a little zoom of the screen so that it becomes very much visible for you. So here is the value of pi, this is the value of diameter, that is d, and this is the L or the height of the tank. So d and L are in meters. So subsequently the tank base area, that is pi by 4 d square, will be in square meter. The tank capacity in cubic meter can be found out. All the formulas have been fed into here. Pi by 4 d square into L is nothing else but the surface area or the volume, the volume of the tank. So that will be tank capacity in cubic meter. 1 liter is equal to 0.001 cubic meter. So by that conversion, this becomes 15,714 liters of the tank. So friends, let us prepare a data table now for this. Here it is on your screen. So if at all the diameter goes on changing from 2, 3, 4, 5, 6, 7, 8, 9 meters and the height goes on changing from 3 to 8 in increment of 0.5 meter, what shall be the value here? Okay, so this tank base is nothing else but the area of the base of the tank, and that is in square meters. So if you see the formula, it is pi by 4 d square. That's all. L has got nothing to do with this. So it is not the volume. So it is the area. So in this case, if we want to check the, I already explained you how to prepare the data table in the earlier worksheet. If you wish, I'll do it once again here for you. So I'll take these as the values. I'll put it here. And for this radial values or the length values and these diametrical values, what shall be the resultant? So if I say this is L and this is D, so the diameters are seen very much within the column and the height or the length of the tank is seen very much in this. Or let it put it other way, I'll put D here and L here. So the diameter is seen in the row and the height is seen in the column. So for this variation, what should be the what if analysis data table, and I say for row input, that is diameter, I'm going to choose this as the input, that is C3, and for the column input, that is the length or the height of the tank, I'll be choosing C4 cell. Okay, once done, I'll say enter and the data table is ready here. As I explained you in the earlier worksheet, this cell is reserved for the result values. So now if I wish to see what will be the volume of that tank, I'll say equal to, and the tank capacity in liter is represented by the cell C9. I will choose it and say enter. So as a result, I'll be seeing these values in cubic meter or liters, right? So liter is the unit for the volume. I'll just format this properly so that it becomes easier for you to see the values here. And now let me zoom it a little bit. Fine. So These are the values, those are now on your screen. So if the diameter changes from 2, 3, 4, 5, 6, 7, 8, 9, 10, and the height of the tank changes from 3, 3.5, 4, 4.5 up to 8, for the corresponding value of say d is equal to 2 meters and the length is equal to 4 meters, the volume of the tank shall be nothing else but 12,571.4 liters. Now in case if I don't want to see the volume of the tank, I can change this parameter to the area base of the tank. Now friends, as we saw in earlier part of this video that a part or portion of the data table cannot be deleted, one sees can't change part of the data table as a warning here, and part of the data table cannot be deleted. The reason being that this cell is parameter of both the x value and the y value of this matrix, that is the row value and the column value of this matrix. So if at all one has to delete a data table which has got two variable here, then it has to be deletion of the complete data table like this. Okay, I'll say Ctrl Z and I'll show you now how to find out the area of this. So as I explained you in the earlier case, I'm going to custom this cell. I go to custom and here I say this and say okay. Cell value is hidden now and now you cannot see the cell value. Now, so now we have seen how to custom the cell, and now the cell H24 is not visible in any case to anyone. Now let me explain you how can we change this from the tank capacity, that is the volume, to the tank base, that is the area. So on cell H24 I say is equal to and choose cell C7 that gives the value of the area, and when I say enter, the complete data table gets converted into the area data table. Now in this case if you see all these values in each column are same irrespective of what is the length or the height of the tank. That is because the area of the tank is not the function of the height of the tank. So in this case, if I decide to delete these column cells, there won't be any impact on any of these values here of the area, because area is not function of the length or height of the tank. So here I have demonstrated you how the area can be, or this data table can be converted into an area data table wherein it is a single variable or single parameter data table now, whereas the volume data table was parameter of two variables, that was diameter of the tank and the height of the tank. So if I choose to see this height as something like this, there it is. Volume can be derived for the different diameters of the tank and different heights of the tank in this way. So friends, I hope you are very much clear with these two examples how the data table can be brought into use in your regular day-to-day life and applications. May it be technical, non-technical, financial, non-financial, simple or complex. With this, I am coming to the closure of this video. I hope you have liked it, enjoyed it. Please express your likes at the channel, and if not subscribed yet, please do subscribe the channel. I will visit you again with my next video soon. Till then, have a nice time. Bye bye.